main concept? Tell your neighbor, please. What main concept are we still on? One variable equations. So, yes, sir. You don't need a fair model because what I'm going to do right now, I'm going to have you turn to your neighbor. And there's a Freire model. It's blank. And on your Nearpod, I'm going to forward the screen of a blank Freire model. Lock your toolbar. Together with your neighbor, fill that in, please. I need at least one clear definition. Don't look at your notes. I need two examples. What is our main concept for today, everyone?
Absolute value.
No, that's the lesson.
Yeah, Caleb.
What's our main concept, everyone? One variable equations. So I want a definition, two examples, two non-examples, and three hashtags. I'll give you guys some time with your neighbor. Ready, go.
How do you make the letters?
So basically, guys, we pretty much know by now what they are. We know the steps that we've been using: simplify, isolate, plot, check. But for the purpose of today, we have three different steps. Write these steps down, please. Step 1, isolate the absolute value by using inverse operations. Step 2, write two equations without the absolute value symbol. And step 3, solve each equation. Write those down, please. So we're going to revisit absolute values. And I'm pretty sure in the past, your teachers, when they approach absolute values, they told you that anything that was an absolute value, it was always what? Positive, right? Okay. Well, for today, hopefully, if they didn't explain the why, hopefully today we'll cover the why part of it. So what are absolute values? Let's see. Absolute values are the distance of a number away from 0. 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 The symbols that we use are these parallel bars. Now, why do we use those bars? Because it shows the distance from a number to 0. Everybody do that? A number to 0, so that you remember the two bars. So what is an absolute value? The distance of a number away from 0. Does that make sense? So once again, the two bars represent a number away from 0. So what is that absolute value? The distance of a number away from 0. We get the point?
Yeah.
Okay, so hopefully if they didn't explain it before, now you know, right? So what is the absolute value, everyone? Number away from 0. All right, so we get the point, yes? So what if I approached it like this? Watch. What is the distance of negative 23 away from 0? Let's see. So how many steps? 23 steps. That's why we don't say, oh, anything that comes out of the absolute value. What comes out? What are you talking about? Nothing comes out. What it is that what is the distance of a number from 0? Does that make sense? Yeah. Now, try to get that in your noodle, because by the time you get to higher mathematics, it's no longer going to be from 0. The absolute value is going to cover distances away from certain numbers. That's what the absolute value will be. It's just a distance. And distances are covered in what? Positive numbers. It's kind of like if I asked Cassandra, I said, Cassandra, step outside, and I want you to count the steps from here to the front office. Go heel to toe all the way. So she goes 1, 2, 3, and gets to 1,305. Okay, let me go back. All right, so by the time she gets back here, don't tell me she's going to go like, oh, -1, negative. No. Distances are counted as what? Positive numbers, okay? Another way of writing this, instead of saying what is the distance of negative 23 away from 0, we can say what is the absolute value, because what is the absolute value? The distance away from 0. Does that make sense? And what do we use? What symbols? The two bars, because from here to 0. Does that make sense? So therefore, what is the absolute value of negative 23, everyone? 23, Michael Jordan. So, we get the point, yes? So check this out. So what if I posted this question? What number is 23 steps away from 0. So now we don't know the number. So what goes inside of the absolute value if we don't know the number? X, that is correct. So we have what number is 23 steps away from 0. Let me illustrate with a number line really quick so you guys can see it. Here it goes. Here's my number line. Here's 0. So what number is 23 steps away? 23, 23. And also, what other number? Negative 23. Therefore, check this out. Now, that's the main concept. Now, computationally, what does it look like? Step 1 says what? Caleb, read step 1.
Isolate the absolute value by using English operation.
So look at the equal sign here. Here's the absolute value. Is there anything outside the absolute value? What I mean is there anything multiplying it, or is there anything adding and subtracting to the absolute value? No. That means it's already isolated. Focus, please. It's already isolated. Step 2, Jocelyn, read that for us.
Okay. Write the two equations without the absolute value.
So at this point, computationally, this is what it looks like. We write two equations without the absolute value. So whenever we see the absolute value already isolated, at this point, I'm going to write two equations. One for the negative side and one for the positive side. Does that make sense? Now check this out. So what I'm saying is that x is equal to negative 23, or x is equal to positive 23. And how do we write our solution? Solution set, negative 23, comma, 23. Does that make sense? All right, copy this next one, please, on your paper. Example 1A. Says, solve the equation, absolute value of x equals 12. See if you can do that one by yourself. I'm going to forward your screen. Let's see. Sorry. There it is. And I'll leave that example up there in case you need to see that one. Yes?
How do you draw the squiggly line?
Oh, the squiggly line is like if you're going to do an F, but without the little bar, and then an upside down F or a backwards F. So the squiggly is like this. If you're going to make an F like this, you know how you put the little bar right here for the F? But then you go the opposite way. Yeah? All right, let's see. Question. Is the absolute value already isolated?
Answer.
Yes. So therefore, we write two equations. X equals negative 12 and one positive. X equals positive 12. Solution set, negative 12, comma 12. Yes?
Good for the negative first.
I like the negative on the left side because it reminds me that on the number line, where are the negatives? On the left side. Does that make sense? Yeah. Yes. It doesn't really matter. As long as you give me the correct answer in the solution set, that's fine. For this case, that's fine. All right, so copy this next one, please. Yes, shoot.
Why the solution set?
I'm sorry?
Why the solution set?
Because we're going to get more into defining solutions such as using domains and ranges. So I need you guys to get used to the solution set. Okay? Copy this one. Let's do this one together. Question. Before you do anything else, we have absolute value, and then minus 3 equals to 23. Is there anything outside the absolute value on this side of the equation? Yes. What is outside? Minus 3. So I'm going to draw a line down, and I need to isolate the absolute value, so I need to get rid of the negative 3. Therefore, add 3, we're left with absolute value, x equals 26. And do we know what to do from there? Yes. So from there we write our two equations, one negative, That's negative 26 equals x. 1 positive, that's x equals 26. Our solution set is negative 26, comma 26. Yes?
So you basically solve it like a one-step equation, but you choose the positive or negative answer?
Right, did everybody hear that? You're basically solving like if it was a multi-step equation, but with an absolute value. However, right now if you notice, there's nothing else inside of the absolute value except x. That's why we're done at this step. So you're saying, uh-oh, are you prepping us for something? Yes. Copy this one, example Q. Absolute value, x minus 4.5 equals 10. Okay, writing utensils down really quick as soon as you copy. All right. Question. Is the absolute value isolated already? Yes. Here's the absolute value. There's nothing multiplying it, and there's nothing adding or subtracting. So at this point, we write our two equations. You're saying, but it looks kind of funky, Mr. Q. Yes, it does. One for my negative 10, and what's inside of the absolute value? X minus 4.5. One for my positive 10, x minus 4.5. Read the last step, please. Gio. Solve each equation. What do we do from there, everyone? I know, but what do I do? Add 4.5, add 4.5. This becomes x equals negative 5.5 plus 4.5 plus 4.5, and this is x equals 14.5. My solution set is negative 5.5, comma 14.5. Copy that. I know some of you are looking at it like, whoa, this, all of a sudden it jumped from number 1 level to like 4 level, right? Yes.
What if it was like two absolute values, and it's like there's like an absolute value on this side and then an absolute
Damn, no. All right, here we go. Copy this next one. See if you can do this next one by yourself. Example 1C. Let's see how you do. I'm going to forward your screen. You can lock your toolbar, and either you can send me a picture or do the work on the screen. Ready, go. Okay, copy this one, example 1D. 1D. And let's do this one together. Same process, same idea. We have 3 times the absolute value of x plus 7 equals 24. Before you start, though, a common mistake some students make, look up to the screen. They see the absolute value, they think, or their brain thinks it's a parenthesis. If it was a parenthesis, what would we do? Distribute. But is it a parenthesis? No, we're looking for a distance. Therefore, you cannot distribute the 3. So if we cannot distribute the 3, tell your neighbor what you need to do with that 3. That is correct. You divide both sides by 3. Divide both sides by 3. Make a note for yourself. Don't fall into that same mistake of distributing. Yes?
Wouldn't it be 7 over 3 though, from like 2.1, 2 1/3? You divide the whole over 3?
If you were to distribute, yes. But we're not distributing, right?
Oh, okay, yeah.
So we're just getting rid of the 3. It's kind of like doing this. Look up to the screen. It's kind of like doing this. What is 3 over 3? And we're left with x. But now instead of x, we have an absolute value. So we bring the absolute value down. Equals 8. Do you know what to do from there? Yeah, finish it off, please. Who's next? Anyone? No? Okay. Solution set, negative 15, comma, 1. Hands if you got that. Okay? We're good, yes? All right. Let me switch the gears a little bit and see how you do with this next one. Copy this one. Example 2A. (2A) says, negative 8 equals absolute value x plus 2, close the absolute value, and then minus 8. Okay, what would be our first step from there? Livia, add 8. Add 8. We end up with 0 equals absolute value x plus 2. Okay, look up to the screen. I don't know if you noticed we have a dilemma now. What did we have before on the other side of the absolute value? Either a positive number, right? But now we have a what? So let me ask you this. Before we used to do two equations, one negative, one positive. Can we do that with this? Why not? Tell your neighbor, please. That is correct, because 0 is neither positive or negative. So therefore, at this point, we only do one equation. 0 equals x plus 2, and we solve. Minus 2 minus 2, negative 2 equals x. My solution is negative 2. What can we conclude? If the number opposite or on the other side of the equation for an absolute value is positive, how many solutions? 2. If the number is 0, how many solutions? 1. All right, home play for tonight is play sheet 2-7 is over here. Bottle, see you in tutoring. See you guys tomorrow. Bye.
Okay, I'm sorry.
Be nice. Whoa, my goodness.